Good morning, good afternoon. Welcome from wherever you are in the world today. My name's Guy Bottle. I'm the product marketing manager for the Geomagic portfolio at Oqton. And today I'm going to be hosting this webinar alongside two guests. As you can see on the screen, we'll be taking a look at Geomagic Freeform and some of the applications that we have been seeing it being used for in O&P design, in particular using automated workflows to aid in the design of orthotics and prostheses. Today I'm joined by Dave DePinto. He's one of our product owners here at Oqton, and Matt Fisher, who is a applications engineer at one of our partners, Hawkridge Systems in the US. A little bit of housekeeping just before we get started. If you have any questions throughout the webinar, there's no need to wait until the end. Drop them in the questions panel in the GoToWebinar control box on your screen. We've reserved 10-15 minutes right at the end of the session to get these answered, but if anything comes to mind, then feel free to drop it down. I'll be monitoring it the whole time, and we'll be opening up for a Q&A at the end. So without further ado, I will stop talking and pass you over to our two experts.
Well, thank you for the introduction, Guy. Hi, everybody. My name is Matthew, and as mentioned, we're going to be talking about, scanning and modeling, and specifically using kind of digital workflows for the O&P designing. So we have a traditional mindset of how we kind of traditionally make different prosthetics or medical devices. And what we're going to talk about today is just a digital version of that workflow and where it can kind of fit in and where we see people benefit from this, professionals and patients. So here's kind of a quick rundown of our schedule for this presentation. So we're going to start off with talking about what is used for that digital workflow, what is professionally being used at the moment, where we are seeing benefits of these digital workflows and how it works alongside traditional methods and potentially even replaces some of them. So where we see ROI benefits for professionals and patients. And then after we've talked about it a little bit, we'll show how that actually looks. So we'll go over how does scanning work when it comes to scanning a patient, how do you process that data? So kind of a general dipping our toes into that realm. And then I'll hand it over to David, who's going to talk about the modeling side of it. So now that we have our scan data, our mesh file, our digital representation, how do we design around it to actually make printable items? And what are some of those automatic workflows? So that way it makes it really easy for high patient throughputs. And then, we'll have a Q&A at the end. So if there's any additional questions you might have, we will set that aside. As mentioned, you can ask any questions you want in between, and we'll try to get to them if we can, but we do have that set aside time for it. So let's just start talking about the tools in particular. So what is available for professionals to start with this? So when we think of traditional workflows or CAD in general, it's creating the molds and then designing around those. We have some software to be able to create some fixtures and features. But when you move into a digital realm, there's a bit more breadth in the tools that we have access to. And we have access to specific workflows or tools for medical devices. I kind of call this the big three for digital workflows. You might see them a lot being intermittently used as the term additive manufacturing, but this idea of scanning, designing, and then printing is pretty popular. And like I said, there's specific tools that allow it to kind of thrive in the medical industry. And using those proper tools just is very helpful in different ways. So if we're going down these kind of three categories, and we'll start with scanning, what we see a lot is something called structured light or photogrammetry-based scanners for medical needs. If you've ever seen a scanner, you can know that there's different forms of it. There's tripod-mounted one, there's lasers one. Structured light is just another form of it. And it's very popular for the medical world because it is very adaptive to freeform shapes and the movements of people. If you ever look at a laser scanner, it's very high accurate, but people can't stand still, which is why it's very popular for sheet metal or mechanical shapes. So the structured light scanners kind of specialize in this ability to capture the curvatures of people and remove that outlier data, so that way it's a lot easier to work with that data in particular. when we move over to the design realm, we have access to things like sculpting CAD software, which is really great for form-fitting in organic parts. So, there is traditional modeling if we're wanting to create fixtures, but the sculpting-based digital workflow allows for a better interaction with the 3D scans made from people, whether it is a CT scan or a physical scan. These kind of sculpting softwares really specialize in the ability to create form-fitting parts. And then moving over into the printing realm, SLS, SLA, and multi-jet fusion, these are the kind of resin or powder-based printing form that allow for high curvature and specialized textures like infill geometries, lattice structures, specialized material that maybe is softer or non-marring to certain surfaces. And you kind of get access to a lot of these by using the digital CAD software, because you can just send your modeled up creation into a 3D printer, choose the material you want that fits for the customer or fits to a shape. So all three of these are kind of, like I said, this kind of encompassing umbrella that allows for digital workflows, and they each specifically fit in different needs. So scanning kind of covers the ability to capture the person, the designing allows for the creation of your parts, and then the printing allows for the actual manufacturing of the items. And they kind of work really well with spots that you can have bottlenecks. So it is important to understand where these might be and resolving them first. So because it is broken up into categories, it's not a one-all end-all cure. I mean, you could go all the way through it all with completely moving over to digital, but sometimes these really help out with finding areas that can be improved first, implementing them, and then kind of working from there and automating some workflows. So these are just some examples of commonly asked reasons for getting into the digital design realm. One is high cost and lead times for sending out molds. Well, scanning can kind of fit into there. You can digitize your molds and then send them out via an email, much quicker, much cheaper, and you can create large categories of existing parts through this by using the scanner or scanning people. When it comes to patient follow-up, it can be difficult to travel and you have to make some constant adjustments. Well, working in that CAD software allows for adjustments in the digital file, and you can work on it remotely without the patient needing to return. You can give them a call, ask how the things are fitting after it's been sent to them, and if they have to make any adjustments, you can do it on the CAD file and then send it out. No need for the patient to come back in. And then finally, when it comes to customizations and these textures with 3D printing, this kind of opens up new realms of what you can actually assist with and creating more customized parts for your patients so they feel more comfortable using them. So as you can see, these are kind of just specific areas in which we commonly see people ask about digital workflows for their needs, but there are other benefits and ROI that can come out from it as well. And again, we're breaking this up into categories because this technology fits into different realms. We're not necessarily replacing traditional methods, but we're trying to assist with it and make life a little easier. And again, when it comes to scanning molds, easier to send them out, you're reducing certain costs, and so you get ROI and more automation and more possibilities. So this slide is just talking a little bit more about some additional ways that we see professional motion patients use digital workflows in the medical field. Again, breaking it into the three categories, we have scanning. You're reducing material costs just generally by using the 3D scanner. You don't have to worry about plastering and mold making as much. You also can create digital inventories, so you don't have to have so much of a physical warehouse space against sending out molds. You're reducing this by bringing it into the digital realm, creating your internet-based cloud server storage and making it easier to share. And also you get your results in seconds. It only takes a couple of seconds and maybe a few minutes to get a process scan, which we'll show later, which is much quicker and it's non-contacting compared to a lot of the traditional methods. We're going into the designing realm, virtual follow-up care. We've already emphasized that a little bit. Another big area is the consistency and regulatory needs to conform to patients. So by using CAD software, if something needs to be 3 inches in size, you can make it 3 inches in size consistently every single time, which really helps out with creating conformities and getting it to match and making sure you're meeting all of your regulatory needs. And the decentralized workspace, it's something that is very important. Being able to just work on the fly, create your parts wherever you are, and working with your different digital data is very paramount for the quicker lead times that can lead to better patient experiences. And finally, going into the printing realm, just reemphasizing the complete customization of shapes and designs. It's the more possibilities that you can assist your customers with, and objects that can actually be made. If you've ever seen printers in the past 10 years, they are just rapidly advancing with more materials, and this again allows more access to parts that can be made. And kind of the last two is a very high benefit for the SLAs or multi-jets is bulk printing and printing overnight. So, instead of having to physically make the final touches of the part or make the actual wrappings for your castings, you can send them to a printer at the end of the day. They build overnight, and then you come in the next day and you just unpack and you have your parts ready, and you can nest multiple parts in. So instead of having to build one part at a time, you can now build 4 or 5 overnight. So you're not only getting a increased ROI by printing while you're not even there, but you're also printing more than one at a time. So all these three together, again, they fit into different realms, different bottlenecks that cause a patient to want, or a professional to want to kind of move into this digital workflow. And they fit into different needs. And it's, again, not a complete encompassing. It fits into specific spots that you can kind of focus on and resolve first. So with that kind of discussed, that's a very top level overview of where we're seeing these scanners being used and why they're being used for certain situations. But how do they actually work? A big part of the unknown is just seeing what it looks like, and that way you can put the one-to-one on, okay, this is how scanning kind of fits into this realm. And so what we'll talk about now is just the idea of scanning people and actually working in that digital environment. So before we can show scanning of a person, let's just talk a little bit about how scanning people compare to, traditional scanning, which is, mechanical shapes and whatnot. First off, it's not very different at all. You're scanning essentially with the same approach. You're making sure you have a good field of view, good distance around the person. But there are just a few things that you want to keep in mind. One is that structured light scanners are light-based, and human skin is fairly translucent. As such, maybe using some kind of makeup or baby powder, it's very common to help with some transparency issues, especially in the webbings of fingers. So this is kind of a little bit of a physical touch on a person, but it's not needed all the time. And it's a lot easier to wash off than some kind of plaster. And it only takes, again, a couple seconds versus the minutes it might take with plastering. When you're also scanning patients, you want to start where they're likely going to move first. So areas like the fingers or elbows, spots that no matter how still you are, you're still going to move a little bit. You want to minimize the noise in this area, which is essentially outlier data, just movements that the scanner captures. So we always recommend starting with scanning where a patient moves first, so the fingers, and then move into more bulk areas that are a lot easier to stand still with. And then last, we always recommend creating an extra 1 or 2 scans if possible, so that way you have more data to work with. When we show the processing side, you can see that you'll actually be able to break up scans into different individual components and recombine them together. So having extra scans just makes it a little easier to ensure you have complete coverage of the patient to design around. And a lot of these cases, at the very bottom, talking about elastic castings and fittings that deform, these kind of same principles apply, starting where it would move the most, and then keeping its minimal movements to a minimum, so that way you don't create any incorrect features or sizings. So let's just now show some of the scanning. So this is a quick video just showing scanning patients in different positions, so you can kind of see what that workflow looks like. I have the time stamp at the bottom of so you can get an idea of what scanning in these different positions are like, and you can see that consistently it's about only a couple, a minute or two, a few seconds, and it depends on what part of the person you're scanning as well. So this is an Artec Ava. So this is one of those structured light scanners, and it's scanning. Kind of explain what you're seeing on the screen, it's scanning at 12 frames per second. So every time you're seeing it flash, it's taking a photo of the person, and it's trying to match that photo to the next one and creating essentially a panorama of the person, which we see represented in the software right there. The different colors are just our offset distance. So we're making sure we're at a good distance close to the patient or too far away. Green is more ideal. And you just saw for a second that it did lose tracking, but as long as we can get it back to a spot it scanned before, it's able to regain that tracking. So this is, again, why it's key for using the proper scanners for scanning patients. those slight movements can cause a lot of scanners to lose tracking. So you want to use a scanner that kind of specializes in the ability to regain tracking, if slight movements have happened. So we're just kind of moving around, just making sure we get all coverage of the, multiple angles of this person's hand, to design a cast around. This is just one position, however, and a lot of times people design different setups to make kind of holding arms still or feet still easier. Here's another positional version, scanning the same person just in a different angle for their arm, and this one is now straight out. Because we have an easier time getting around the patient in this angle, you can see that our time to scan the person is cut in half. So this is, again, kind of emphasizing that getting a good setup allows scanning patients really quick and really easy. And depending on the body part you're scanning, you can create different setups for it. So, we're just walking around the patient again, just trying to get a good coverage of everything, multiple angles, multiple positions, just getting that full coverage. And this is essentially what would be represented by making a mold, but we're just doing it in a non-contact, scanning form. Do the same with scanning a foot. So here we are kind of using a sock to make it a little bit easier to scan different angles. Not necessary at all. Also not necessary to put the leg on a chair. Some people like to use kind of a plexiglass setup for it. But you get the idea that it's, from these 3 videos, it's essentially the same approach over and over again. You're making sure you have a wide area around the patient. You're getting multiple different angles around the patient as well. Just making sure that what you see on the screen is a full coverage of the part that you're trying to capture. And this is what, again, will be processed into what takes place for the mold. And it's non-contact and it's very, very quick. So we'll kind of move on to the processing side. So at this point, we've created a couple of scans. As you can see that they are represented in our software right now. Different scanning scanners have different software that work particular with that data, but the basic workflow is essentially the same with each one. You're going to clean up your data once you have it. You're then going to fuse it together or triangulate it into a finished mesh, and then you can do a little bits of post-processing afterwards if needed. So what we just did right there is called global registration, that first step, and then we're going to erase a lot of the unnecessary data. So what global registration does is it's just kind of taking all those loose scans, tightening them up. We erase the body so that way it's not part of our finished scan. We removed a couple little outliers, and now this final step is the actual fusion process, actually what is going to create our mesh. Processing time, is still very quick. By scanning and including the processing time, it's essentially 200 seconds or a little above, 3 minutes or so, to go from having absolutely nothing to a finished mesh file or finished digital mold, which we can see right here. So we're going to rotate it around, make sure it's cleaned up, but generally speaking, at that point, we are ready to go. Just going to repeat the steps again for a different scan. So this is using a little higher quality data than the first scan, but we're still going to do that global registration. We're still going to do that fusion to create the mold. And here's where we kind of get a little dip of the first set of automation. We know the processes we want to run, so we have an auto mode to just say, yeah, run those 3 steps or 2 steps sequentially, and we can step away. No need to manually click anything, and we create our mold again. And we can just, again, keep repeating this process for different scans. So one of the things I really like to emphasize at this point in these kind of presentations is that when it comes to scanning, a big unknown is what it looks like, but it is a very similar workflow over and over again. You're creating that representation of the person in the raw data. You're going to clean up that raw data so that way it's a little better when you create the finished mesh, and that finished mesh is the finished mold or equivalent of the mold, the representation of the patient. Here's an example of just how we can clean up data a little bit better. So what I did right there is I noticed the scan, the patient moved a little bit in the forearm. So I just took the most important feature, the hand. We removed the outlier parts of one half of the scan, the stuff that moved a little bit, and then just reform them together so we can create a new finished mesh that is very clean and proper to design around. And we don't have to rescan the patient. We're just working with the data we already got by just erasing unnecessary stuff, splitting it up where those extra 1 or 2 scans can really benefit. So, this is working, so we've created our mesh, but what we can also do is a little bit of post-processing. So what I'm doing right here now is, that's the foot of the scan with the sock. Socks have some texture on it. We don't really want that to be translated into our modeling side of the step, sorry, tongue twisted, modeling side of the process. So I can smooth it out essentially. And what we're doing here is we're just taking that mesh file, we're taking a smoothing tool, getting rid of some of that texture on the sock. So, we're not just stuck with what is captured. This is really the benefits of that digital workflow, is the ability to say, hey, this isn't exactly what we need. Let's erase it a little bit. Let's edit it up a little bit. And we don't have to restart from the beginning. We don't have to make a new mold, but we can take what we have and get it to work a bit better for, the next steps. And one of the other crazy good benefits of working with scanners is the ability to use color. So what I'm doing right here is I've reduced the mesh down by 90% of its file size, so making it much easier to ship out through email. But I'm also now applying a colored texture to it. So if we have markings on something, maybe we've scanned an existing mold and we have some pencil marks on there. The patient, we have distinct features we want to make sure we highlight. We can do that by using the color capabilities of scanners. So, at this point, we've now gotten our mesh file. We've created essentially that mold. We've gotten the representation of the patient. But now we run into a commonly, found issue is, okay, we have the mold, but how do we actually create the thing to design, how do we design around this? How do we actually create the casting or the medical device that we need around this patient? And this is kind of where, using a CAD software can fill that gap. So you're going from scanning to printing, you need to actually create, different representation, or design around that to send it to a printer. Now, if you've ever seen anything CAD-wise, there's kind of two main branches of the CAD world, parametric and sculpting base. Parametric is a feature-based design, very useful for hybrid modeling and creating fixtures. So, what we see on the left side is a hand model that has a more gear-based back end of it, so that way we can, mimic certain clicks. That's parametric. Sculpting is more freeform based, and it's great for working directly with scan data for fitting parts, which is exactly kind of what we'll show off in just a moment. So these two kind of categories really fit into the, can be used to, again, create your different parts, follow up, making sure you're fitting into certain regulatory needs, and actually create something that is able to be printed. So I'm going to hand it over to David at this point, who's going to talk about Geomagic Freeform, which is a very popular industry standard for creating medical devices off of sculpted or off of 3D scans due to its sculpting and parametric modeling capabilities.
Thank you, Matt. I'm going to take the screen right now. And right now I am showing the final result of a scan that had been done by Hawkridge some time ago of this is of course only the ear. We have the rest of the model that I will show off in a moment. But speaking about Freeform as a design tool, this gives you the power to mix and match both parametric design, freeform design, sculptural work, and it's done in an intuitive sculptural sort of way. Since I can hide this ear, you can see that this model now will conform to the inside of that cavity, actually, that there was a standout for a battery. And of course, the high resolution of data, the excellent scan that was done does give us a small view into the ear canal. So we have everything we need to make a hearing device. Going about this is a little bit challenging to think about, but fortunately, Freeform is very user-friendly, very easy to learn. So I'm going to take the result of a scan. So this is scan data that was processed in the exact way that Matt was talking about. And if I do remember correctly, yep, this here is actually Matt's face. You can see that this scan here is aligned in the world off of what we expect, but it is a very high quality, very good representation of the area that we're looking for. we do need a little bit of area around the ear, and we need the ear. So you might say, okay, we have this, now what do we do? There are so many different approaches you can take in Freeform to create an object. So if I wanted, I can use a sculpting tool and simply add some clay. Actually, I need to construct, add clay, and what I will do is just begin with a brand new piece, take a lump of clay, and stick it inside the ear. That's not a very good medical device now, is it? We can deform this by tugging and pulling on this. And right now this here will fill the ear cavity, and it's kind of ugly. I can smooth this using sculpting tools. So make this a bit larger, smooth this down. And what I need to do now is I'm going to take Matt's head and I'm going to remove it from this piece of clay, leaving us with a representation of the inside of the ear, as well as a small region that was left over and stuck out of the model where I just didn't clean it up very well. But we can smooth this and make this look a lot nicer. And this is an accurate representation of the inside of that ear. I wouldn't call this a medical device, but this here is the rough idea of what you are ultimately looking at, building something based off of a piece of scanned data. Now, in order to make a quality part, there's going to be a lot of different steps and a lot of things to consider. So obviously, doing things like sculpting, which, as you saw from the video, this tool here does have an external device, a force feedback haptic touch device, which allows me to touch and feel. So for everything that I'm doing on screen, I'm actually getting a level of feedback that is completely unique to this design space. I can touch and poke and actually interact with this as if it were a physical object. Going to remove this piece of clay and go back to the scan data. And from here, we're going to take a much more logical and metered approach. So one of the things that we have to do is align the scan data. One thing that is very common when you use a 3D scanner, the data will be aligned either directly in the center of the world, or sometimes it's actually offset depending on the scanner and how it's processed, where it may be relative to where it was scanned. So if you start a scan and your arm is somewhere off in space compared to where the device thought the center of the world was, you have to reconcile getting your data into an appropriate location. So if I look at this from the front, you can see that the head is rotated, and I can do this manually. So using my haptic device, I can reposition this, and I can rotate this around and flip this up and actually pull it into place. I want to be looking at the ear, rotate my view, and we'll see that I pulled it forward, so now I pull it back. And while that is fairly easy to do in this software and it feels intuitive, it's also a very manual step. From here, I want to create a digital clay version of this, which I can use for various tools. Most of the tools inside Freeform are based on digital clay. This is a voxel representation, which is a volumetric representation, which gives us slightly more accurate offsets. It means that when we perform certain operations, we don't have to worry about the surface quality, and we don't have to worry about issues with the data like self-intersecting faces or other things that can come up if you're doing mesh modeling or solid modeling. So I'm going to begin by selecting a region. I want this ear. So I'm just going to pick these faces, and I will copy them as a brand new piece of clay. And I need to thicken this because the mesh representation is only just a surface, where the clay is an actual volume. So this has to have some type of thickness to it. So I will make this about 3 millimeters thick and change this to about a 0.5 millimeter resolution for the sampling, and click apply. Now that we have, 0.5 millimeter was not enough. So thicken, we'll do 3 millimeters, and I want 1/4 millimeter. This will all come into play very soon when we talk about automation, because right now I forgot these steps and the values for what I'm using for converting my data. This is something that happens, especially if you're a designer doing things repeatedly. You can misclick, you can forget, any number of things can go wrong. So I'll click apply, and we have this representation of the ear. So if I want to design based off of this, one of the things I can do is duplicate this. So I have a fresh copy, and I am going to copy this entire thing and make this a protected volume. So anything that I add on top of this will be able to be separated from this later. So now, if I want to, I can define a curve and pick something here on the inside of the ear. And fill this in. So now I have a region on the inside of the ear. So basically everything behind this to the inside of the ear cavity is going to be filled. And I can tug and pull this around. And of course, now if I want to remove the ear, I am left with the internal piece of that model. There's a lot of cleanup work, there's a lot of additional work, and of course, in order to manufacture this, there's a lot of other things to consider. This is where automation is going to be your best friend. You spend some time after you get your scan data, and you build up a workflow that works for you, and you can create automated tasks that will take care of the individual pieces of a workflow or an entire workflow. That means you don't have to remember, you can follow along, you can let the computer do a lot of the work. So from here, I'm going to show what that does look like in Freeform. Beginning with the exact same scan, I'm just going to hide the tool palette because we don't need it. And we have a tool called Dynabot, which is a macro recording and automation tool that allows you to record tasks, create some logic, and do a variety of things. And some of the things that I had just done, now I'm going to do in an automated way. So I've already put this together. So the first thing I want to do, and you can see that you can create a custom graphic and text and an interface. This here is all done in very simple HTML, where it's telling me that to begin, draw a curve to do an alignment on this. So make a curve and press continue. Now, the tool was automatically changed and it has set up all of the preferences for me. So now I'm going to create a plane. So I just select a few regions on the ear, click continue, and it had done it created a brand new plane, used that curve, and did the alignment for me. So now you can see that this here is aligned in the world where I want it. And I didn't have to do anything besides define a vertical line and a couple spots on the mesh. The step that I had a small mistake with a moment ago, which was converting this to clay, this is telling me now to make a selection. So I can come over here, just make a big selection on the ear, make sure I've got everything I want, click continue. And I am not doing a thing. This followed all of these steps that I recorded, and now I have the base model to begin working on the design. Right now, each of these are in individual scripts. These can all be combined into a single workflow that you can progress through, but having them individual does allow you to stop and go back or interrupt your process if you need to. So there's a lot of flexibility in here. The one thing I didn't do during the live presentation or the initial part is this is a tool to find the path of insertion. So I will be able to remove any undercuts so the appliance will not have anything getting stuck on the inside of the ear or the backside. So I just have to align my view and click continue. And I continue moving on. All of the tools are swapped behind the scenes. Everything is pre-configured. So all I have to do is follow some simple instructions and do what it is that a human is good at, which is look at the data, determine the landmarks, look at the things that are going to be specific to the patients. And that is the type of thing that you can't easily teach a computer to do. But if you simply pause the tedious work and get the input from the user, the computer can do all of the things that I don't want to do, and I can do the things that are important. So all of that, I had to click only just a small handful of times and follow some steps, and I got the same type of part. And from here, to show you how easy this is, if I create a brand new script, start recording, I can open up my tool palette, and from here, if I wanted to, say, build something in front of this model, like using a 3D curve, I want to create a pipe that I'm going to combine into that piece. You can see that as I am performing all of these actions, these steps are being recorded here in the script. When I stop, I can go back and look at the values, and this is how you can edit them, you can refine them, you can make it so that these are going to drive the workflow that you're going to do later and remove a lot of headache and a lot of confusion, not to mention for documentation and for things like any type of process validation. These are steps that can be basically pointed to and said, these are what we're doing, we're following this, we have all of the data, and there's no room for human error in these parts because the system is well configured to handle that. Looking at the time, we're getting close to the end of this. I think we might want to move on to the wrap up for this so we have plenty of time for Q&A, but Freeform as a design tool does give you the power of working with a digital representation. It gives you a lot of flexibility and the ability to make changes where more automated tools that don't have the rest of the design pedigree can't allow you to fix and continue working, where if something in the data is challenging or if there's any type of issue, you have an entire working suite of tools that are built around the idea of manufacturing to fall back on. That is one of the most important things with this entire package. So I think hand this back over to Matt because we have another video. There's one more thing to go through.
Yeah, just kind of recapping a lot of what you're talking about, and then we can go on to a Q&A. Yeah, thank you for showing that, David. All right.
Thank you.
Make sure my screen is back up again. So, yeah, as David mentioned, a lot of Freeform is particularly great for the fact that you can really manipulate and work around that scan data. So it's kind of, and it gives you that live feedback as well. So you can make, different little changes. You can sketch around it if you want those parametric, those exact dimensions, kind of like how David said, oh, I, didn't make it thick enough. I can edit that up real quick. It's not lost. You don't have to restart from the beginning because you are working in a digital realm. And just creating extremely high-end form-fitting parts to these scans is what you would want to be able to send to a printer when you are working a lot in the medical field. You want that extreme high fidelity, that ability to teach others on how to make them as well. That Dynabot tool that was shown very popular, to be able to just hand to a new user and say, hey, follow these prompts. You can recreate the parts very easily. It's very easy to follow along with those pictures and basic coding. So really handy in that sense. And with that, we'll open up the floor to a Q&A. So, please feel free to ask any additional questions. At this point, we've kind of, talked a lot about the scanning side of it, moving over into, processing that scan data, what it's like to sculpt around it. So a lot of information. Hopefully it alleviates some of it, but we'll open up to some Q&A for additional questions that people might have.
Thank you, guys. That was super interesting. We've got a couple of questions here that have been asked just as we've been going through the presentation. This first one, does Freeform integrate directly with scanners?
Freeform does work directly with Artex scanners. We do have an implementation that you can scan directly into Freeform, but for the best experience, I would recommend using the Artex Studio software. It has by far more capability than the plugin that is developed for Freeform, and that is the only scanner that has any integration right now.
Yeah, and to kind of piggyback off of that, I might have mentioned it a little bit during the first part when it came to processing, but a lot of scanners have specific software that works really well with that scanner as well. And it makes it so editing the scan data, reprocessing it is a lot easier. So as David said, you can scan into it, but working directly with the scanning software can get you some really good results.
Right, thank you. What kind of files can Freeform export?
Freeform can export any type of, common mesh files like STL and PLY. We can convert to solids. So if you are working with a more parametric system, we can auto surface or create manually surface parts and export as SolidWorks part files, IGES files, STEP, or Parasolid. And we can also export for 3MF.
Great. We have one here. It looks like someone is wanting to learn more about the automation workflows that you showed. Have we got any tutorials available for Freeform to learn how to use the Dynabot?
So inside Freeform's documentation folder, we do have a Dynabot training manual and user's guide, as well as a large collection of example scripts. If you open the Dynabot editor and go to, there is a folder for, there is a samples folder, which is actually in the install directory for Freeform. I think I would have to get the actual path for it, but it's We do provide a lot of examples, but there's no specific tutorials available at the moment.
Thank you, Dave. These last two questions we've got at the moment are more around the actual physical scanning side of things. So is there any preparation other than what you showed in those videos, Matt? Is there any preparation that is needed for the patient in order to scan them?
No, very minimal. A lot of people have patients just sit down in a chair, get them to feel a little comfortable so they don't, fidget as much or move around. You're really just trying to keep movements to a minimum. And then, if you're scanning somebody and the data just isn't coming in as clearly as it should, that's where the baby powder or makeup can kind of come in to kind of add some opaqueness. But generally speaking, just have the patient sit down, get comfortable, and then you just fire up the scanner and you can get started right away.
Great. On that note, there is a question here around scanning hardware. So you obviously showed an Artex scanner, but can you scan with any of these new apps, these new technology that you're seeing coming out for tablets, for iPhones, for Androids, that kind of thing?
Yes. So while Artec is, like I said, a very popular one, it's more professional grade and has the processing software along with it. The workflow is generally the same, and there are apps out there to work with iPhones or iPads to scan people. I haven't used many of them personally, so I can't attest to them, but they kind of have the same workflow where you're just trying to get a panorama, and I use that term in quotes, but a panorama of the person with a bunch of different photos. You can check if it works, the LiDAR factor or the structured lightness is the kind of technology behind the scanner, but some of those iPhone apps use a more LiDAR-based, multi-camera system to be able to create the mesh file. So there are apps out there. How well they function, I can't say personally how good they are, but there are different apps out there to help out with the processing. Again, the workflow is really the same. The scanner helps with just that post-processing and the quality of data you get at the end. One thing I will emphasize a lot with those iPhone and app scanners is the quality of the data might look really great with texture, but if you remove the texture from it or that color from the scan, you'll find it's a very blobby, kind of rough looking mesh. And that's actually what you're going to be designing around. So you want to make sure that the data you actually get from the scanner, the actual mesh file, is high enough quality to actually design around.
And professional scanners do test and validate their accuracy. So Artec will actually provide the details for, I believe the EVA is roughly what, 1/10 of a millimeter on average for accuracy.
Yeah, they're very high-end metrology-based ones.
So that is something to consider, the level of accuracy you need, where the photo-based or the other ones that you use with a smartphone or a tablet will not likely have such a high level of accuracy, and they can't guarantee it necessarily either. So definitely something to consider.
Yeah, I guess it depends on the use case, doesn't it? If you're looking at designing a device that, like you were designing for like a hearing aid, which is much smaller with much more intricate detail, it's a very different question compared to, I don't know, like a plate or a support that just needs to be generally the right size. So great, thank you. There's a question that's just come in about the Dynabot. Is it available, or which versions of Freeform is the Dynabot available in?
So Dynabot is available in Freeform Plus only.
And the last question that I've got here is around the time of collecting the data and processing the data. So Matt, how long did it take you to scan, or someone to scan you? I can't remember which way around it was in the video. And how long did it take you to then process that scan data to then take into Freeform?
Yeah, so on average, to scan a full person it takes about 4 minutes with the Artec Ava, which was the one I showed off. I had some timestamps at the bottom of those videos, but to scan the patient's arm while it was just kind of standing straight out, that took about 45-50 seconds to get the raw data, and then about another minute to process the data. So generally speaking, about 3 minutes time to process the individual limbs of a person, scanning and processing. And then for a full person scan, it might take 4 minutes to scan them and then 10 minutes to process. The times differentiate based off of the amount of data you captured. So the more time you spent scanning a patient, the more scan data you have, the longer it'll take to process. And also another thing is, the scanning speed goes by muscle memory, I like to say. So as you scan more people, you're going to get faster, which will reduce the amount of scan data you capture or needed to make your mesh. And that naturally leads to quicker processing times. So as you use it more, your processing and scanning times will decrease, but generally speaking, about 4 minutes on average for a full person, and only a couple, minute or two for individual limbs to scan and get the finished mesh.
Great, thank you. We have another question come through. This one is quite a specific workflow focused question. Say you were designing a custom foot insole using the Dynabot, could you automate the process to give a 10% arch height relief?
Ooh, I don't know if you could automate that entirely. There would have to be some user intervention in order to define that. It doesn't provide enough scripting or logic capabilities to say change a curve by a percentage or move an object by a percentage, but you could handle a lot of the tasks around aligning and building up the data for it. But yeah, there still would be some manual work involved for that specific case.
Right, I hope that answers your question. That looks to be all of the questions that we've got in the questions panel. I want to say thank you to our presenters. Thanks for taking the time to come and talk through this workflow with us. I'm sure you probably all have lots of questions burning that you haven't thought about yet. If you have any questions afterwards that you forgot to ask, then feel free to reach out to us through our website or respond to the email invites to this webinar, and we're happy to get back to you.
Yes, definitely. If you have any other additional questions, scanning kind of CAD design or your sculpting design is my opinion, it's really nice to see the workflow so you can see how it looks. So if you do have any particular questions or, use case that you're curious about, don't hesitate to reach out.
Absolutely. Anything that you want to see, let us know.
Into the chat, I hope this is okay, Matt. I'll put your email address if that works for people to reach out to you directly.
Yes, definitely. You can reach out. We can get connected and go from there, with a further conversation.
Perfect. Thanks, guys. Really appreciate it. Thank you for everyone for joining, and hopefully we'll see you in the next one.
Awesome. Thank you, everybody.
Thank you very much.